Okay, here we go. We got optimization problem number 4. All right, so let's see what's going on. We have this parabola that is upside down with an vertical intercept at 4. So I'm going to draw that just kind of quickly. And I think it looks something like that. Okay, and I've got this 2.24 up here. And I want to know the closest distance that this point is to the parabola. Okay, now some may look at it like this and say, well, that distance is 4, and this one is 2. So I know the distance could be, well, it could be as close as 0 if this point actually landed on it, okay, which I don't believe it does. Okay, otherwise it would have been more representative of the point on the curve. I know it has to be something less than 2. Okay, and maybe it is equal to, maybe this is the closest distance it is. My guess is that there is a slightly closer distance. So, but it's got to be somewhere between 0 and 2. But I'm going to guess this distance is a little closer. I'm going to call that D. Okay. All right, now what am I going to do with D? Well, I need to find the closest, which is basically the minimum distance. Okay, so let's think about the distance between 2 points, x1, y1, and x2, y2. And I think you remember this formula from some time. Back in Algebra 1, x2 minus x1 squared plus y2 minus y1 squared. All right. And the nice thing is I have one of these points, okay? I'm looking at this point up here and the point that's somewhere on that curve. So this is 2, 4. I'm just going to hide this above. Okay, and this other point, I really don't know what it is. I'm going to call it xy. Or how about x, f of x instead? And when I think about that a little bit more deeply, okay, f of x is the same as this guy. So without being too tricky and calling this xy, right above here, just for the sake of room, I'm going to call this x. And instead of calling it y or f of x, I'm going to say what f of x equals to. This is 4 minus x squared. Okay, and now that I've identified a distance formula with an x1, y1, x2, y2, and by having my points in terms of either numbers, okay, or x's, I could input a set of items into this formula and create a function. Okay, so let me set up this design, and we'll look at what x2 is. x2 is, well, just x, minus x1. x1 is 2. y2 is this guy, that is my f of x, which we said was 4 minus x squared. Yeah, that's tough to see, but that's 4 minus x squared minus my y1, and my y1 is 4. All right. Ah, I did not mean that to happen. Where'd it go? Okay, I'm just going to make this a little bit bigger so you can see it. Cool. Now I could put that in parentheses, but it's not going to be needed because it's in the front part of my binomial. And if I want, I could derive that after I do all the squaring, and I'm not going to do that. I'm not going to multiply that out. But I am going to simplify this piece. So 4 minus x squared minus 4, those 4s are going to cancel out. We get negative x squared. And so this leaves me with, well, maybe I will do it. X squared minus 4x plus 4 plus, this will give you an x to the 4th. Okay, so when you derive, okay, kind of consider what happens. Just in a real fundamental term, if I take the derivative of the square root of x, which is basically the same thing as take the derivative of x to the 1/2, that gives me 1 over 2 x to the negative 1/2. And all that really does is give us a 1/2 with an x on the bottom with the square root bar around it. Okay, so same idea. If I want to take the derivative of this, I'm going to have this square root on the bottom, just like I have over here, with a 2 out front. Okay, I'm going to take everything that I see inside here and put it on the bottom. Okay. However, what goes on top is not a 1. You have to do a chain rule and take the derivative of the inside. Okay. Now, when I take the derivative of the inside, I'm going to do it in order, okay, in descending order. So derivative of x to the 4th is 4x to the 3rd. Okay. Derivative of x squared is 2x. And the derivative of minus 4x is minus 4. Okay. And like all of our work, we're going to take this derivative function and set it equal to 0. Okay, now some of you are looking at that thinking, I have no interest in putting this in my graphing calculator. And I have to say, I wouldn't blame you. Okay, because that does look intimidating. However, as you solve, okay, what you have to remember is that when you solve, all you're going to look at is the numerator. Okay, so I could easily say, you know what, I'm going to multiply both sides by your denominator. So 2 times that square root stuff, okay, and do that over here. Okay, so I'm not going to write this all in, but you get the idea. And the same thing here. And these will cancel, okay? And 0 times this is still going to be 0. Okay, so let me write this up here. 0 is equal to 4x cubed, okay, plus 2x minus 4. Okay. All right, now, how do you solve for this? Does this factor? I don't know. I don't think it does, okay? It doesn't. And so what I'm going to do is I'm going to use my graphing calculator to find out what x is, okay? Now, here's what I'm going to do. In order to use my graphing calculator, I have to break out of my PowerPoint screen just for a second. And so I'm going to escape this. Okay, I'm going to keep my annotations. Okay, I'm not going to send that away, but I am going to put up my graphing calculator. And just for the second, you'll see that I plugged it in already. Okay, so 4x cubed plus 2x minus 4. Take a second, maybe hit pause on this video if it's going too fast. Okay, maybe you don't have your graphing calculator out already. Take it out, plug that in. Okay, and I'm just going to highlight this first guy so it'll graph. And when I do so, it goes something like this. And I want to figure out where does it cross the x-axis. Okay, so here's what you're going to do. I'm going to clear this out. And I'm going to figure out where it crosses. You're like, it looks like 1. It does, but it's not. Okay, and the reason why we know that is because we will do the command for finding a 0. So if you look off to the left here, clear key history. I thought I did that. Okay, so I'm going to hit second. Okay, up here in red, you can see it, second, and then you hit the trace, which is calc. I'm going to go down to 2. You see that? All the commands are down here. Okay, and here's what it says. It says left bound. So when you think about this root, okay, this 0, I need to have the cursor to the left side of it. Okay, those blinking dots, and you can see that this little flowered blinking thing is, yeah, to the left of it. So I can hit enter, and it marked it. Okay, and you can see where it's located. And now I got to be to the right of this root. Okay, so I'm going to move my arrow button to the right, and I'll hit enter, and you can see that they've created some bars that surround this root. And if I hit enter again, I get this value. So it's not really 1, it's 0.835122. Okay, so I'm going to escape out of this 0.835122, go back to my PowerPoint, and it likes to let me know. Hope you saw that. 0.835122. Okay. And I'll have to check to see if this is a maximum or a minimum. So let's take a look. 0.835122. That gave me a 0 when I plug this in for my d prime of x. Okay. And here's the deal. I can actually, I'll just finish it the way I would. Pick a number that's lower than it, like 0.5. Now pick something a little bit higher than that, 1. And we're going to plug it into this monster. Okay. All right. So I'm going to make this easy for myself. D prime of x is already in my y1. So I'm just going to do y1 of 0.5 my graphing calculator, and then y1 of 1 and see what I get. I don't know if the bottom is going to be significant because this has to be rooted. And when that's rooted, it's going to be positive. Okay. And when you multiply that 2, that's still positive. So actually, I'll just do this. I'll just plug it in. The first part easy. 1, if you plug it in, gives you 4 plus 2 minus 4, which is 2. When you plug in a half, okay, geez, how about this? 4 times 1/2 cubed plus 2 times 1/2 minus 4. All right, so this is 1/8. Okay, times 4 is a 4th. Okay, plus 1 minus 4. The big deal is that it gives me a negative. It's like negative 2 point. Take that back. An 1/8 times 4. This will be a half. Sorry. So 1/2. This gives you negative 2.5. Okay, and what does that mean? It means you have you're going from negatives to positives. Okay, so negatives to positives means you have a minimum. So at x equals 0.835122, there is a, in this case, we'll call it a relative minimum until we're sure that these boundaries, sorry, not those boundaries, these boundaries don't exceed it. And relative minimum, since d prime of x moves from negative to positive values at x equals 0.835122. Okay, and you don't have to write them all. Write my 3. 835,122. Now I need to fix it.